Okay, moving on to the second section of this chapter, mass wasting and the work of gravity. As you see in this picture is taken from New Zealand, where we have this in February 2011. A huge boulder rock is actually um, uh, went down from the mountain, right? And it blocked the road. So that rock is kind of dangerous if there was people around. That result after a earthquake, right? So earthquake can actually trigger a mass wasting event. Mass wasting is also known as geologists we call it landslides. So we are going to talk about what kind of factors are going to trigger the mass wasting, and we need to define the mass wasting first. Mass wasting is the downslope movement of the rock and soil under direct direct influence of gravity. So the main reason of the downward movement is the gravity, but there will be some factors that initiates and triggers this movement. So we'll talk about what kind of elements are actually playing a role in this movement. It can be an addition of water, it can be oversteepening of the slope, also removal of vegetation, like if there is a forest fire, wildfire, it can be result in a landslide event, and also ground shaking as an earthquake. It can trigger a mass wasting development. So, and we need to add that not all landslides are initiated by one of these triggers. It can happen with no trigger as well. So I would like you to watch this video before doing your homework.
Hello, this is Callan Bentley. Welcome back for another Smart Figure. In this video, we're going to take a look at the role of mass wasting in creating the Grand Canyon. After watching the video, you should be able to break down the respective roles of rivers and mass wasting in producing canyons. So take a look over this scene. This is a classic looking Western canyon. Beautiful example of a river flowing down in the bottom of the canyon, and then these cliffs and plateaus that rise up above it. Naturally enough, you might think, okay, the river carved this thing. And the river is the dominant force in being responsible for making this landscape feature. But mass wasting has a huge role to play. Take a look at this canyon for comparison. This is a slot canyon. It's called the Narrows in Zion National Park. And basically, it's a really narrow canyon. And this is the Virgin River here, that down in the foreground, that has carved the Narrows. Why do the Narrows look so different from that canyon that we just looked at? Some rivers are wide, some rivers are narrow, some rivers have wide spots and narrow spots. Narrow spots are a really good place to put dams because you have to build a lot less dam to span the river. So what's the deal here? Well, it's something like this. Take a look at the Grand Canyon here. We've got a photograph and you can see the Colorado River running through it, and you can see the north and the south rims over there in the far distance, the plateaus that the canyon is cut into. The sketch here in the lower left basically shows what we're looking at. You can see there's sedimentary layers and metamorphic and igneous rocks in the inner gorge, all carved by the Colorado River, right? Well, sort of. Really what the river does is it's responsible for removing material in its bottom. So it scours into the rock underneath it and removes that material. That means that you end up getting one of those slot canyons, kind of like the Narrows in Zion National Park. But having big, steep cliffs that are thousands of feet tall are not geologically stable. So you end up getting landslides that basically take the material on the sides and drop it down into the river bottom. And once that material ends up in the river bottom, the river can cart it away, but mass wasting ends up taking it from the high areas and dropping it down to the low areas. So landslide by landslide, the Grand Canyon has been widened. So what does that mean for the Narrows at Zion National Park? What would you predict for the future of this scene? Well, over time, these sandstone cliffs are going to collapse downward. Hopefully that woman won't be standing there when this happens, but these are dramatically oversteepened, and they will indeed fall in eventually. And underneath this sandstone layer is a weaker layer, a shale. And when that shale is cut into by the Virgin River, it's going to undermine the sandstone in a very big way. And this canyon is going to widen rapidly. In fact, most of Zion National Park is a widened canyon where that process has already taken place. Good job. Thanks for your attention. This has been another Smart Figure.